Why did one German tank become so feared that Allied crews sometimes avoided fighting it directly? The answer was not only its gun, but the engineering philosophy hidden inside its steel body. Among the armored vehicles of the Second World War, the Tiger I stood apart. It was larger, heavier, and far more complex than many tanks of its time, designed to dominate battlefields through sheer mechanical power. But what exactly made this machine so formidable? To understand that, we must first look at its overall structure, from the length of its steel hull to the massive turret mounted above. The Tiger I was not a small vehicle. Stretching over 8 meters in total length and weighing more than 50 tons, its massive size alone already hinted at the power hidden inside. Every centimeter of this tank served a specific purpose. From the thick armored plates to the internal mechanical systems, the entire structure was carefully engineered to survive and dominate intense battlefield conditions. At the center of this structure was the armored hull, a massive steel shell that protected the crew, engine, and transmission. This hull formed the backbone of the entire vehicle. Above the hull sat one of the most recognizable components of the Tiger I, its large rotating turret. This turret housed the main weapon system and allowed the tank to aim independently of its body. Inside that turret was the weapon that made the Tiger legendary, the powerful 88mm KWK-36 cannon, capable of destroying enemy armor at distances many tanks could barely return fire. However, a gun alone does not create a battlefield monster. Behind the armor and firepower was an intricate network of mechanical systems that allowed this massive vehicle to move and fight. To truly understand the Tiger I, we now need to examine its internal engineering, starting with the heavy armor plates that formed its protective shell and defined its incredible battlefield durability. The first element that defined the Tiger's battlefield durability was its armor. Unlike many earlier tanks, the Tiger used extremely thick steel plates designed to resist powerful anti-tank weapons. At the front of the hull, the Tiger I carried armor up to 100 millimeters thick. This massive steel wall protected the crew compartment and became one of the tank's most feared defensive features. These armor plates were not simply welded randomly. Each section of the hull was carefully arranged, forming a rigid steel structure capable of absorbing impacts while maintaining the mechanical integrity of the vehicle. The front armor protected the most critical area, the crew compartment where the driver and radio operator worked. Behind them, the interior space continued toward the fighting compartment beneath the turret. Above this fighting compartment stood the turret ring, a massive circular structure allowing the heavy turret to rotate smoothly. This mechanical joint connected the weapon system directly to the tank's armored body. While the front armor provided extreme protection, the side armor also played a crucial role. Thick steel plates along the hull shielded internal systems and protected the suspension and track assemblies. Inside the hull, space was carefully divided into several functional zones. Each compartment had a specific purpose, balancing crew safety, ammunition storage, and the mechanical systems required to move the tank. Toward the rear of the vehicle sat the engine compartment, separated from the crew by armored bulkheads. This section housed the powerful engine responsible for moving the entire 50-ton machine. Power from this engine traveled forward through a complex transmission system before reaching the drive sprockets connected to the tracks, converting raw engine force into controlled movement across rough terrain. But moving a machine this heavy required more than a powerful engine. The real secret lay in the sophisticated suspension and track system that distributed weight and maintained traction across difficult terrain. At first glance, the Tiger's suspension system looked unusually complex. Rows of overlapping road wheels covered the sides of the hull, forming a mechanical structure designed to distribute the enormous weight of the vehicle. These wheels were arranged in an interleaved pattern, meaning each wheel overlapped with several others. This design increased ground contact, helping the massive tank maintain stability while moving across uneven terrain. Behind these wheels, hidden inside the hull, lay the torsion bar suspension system. Long steel bars connected each wheel to the chassis, allowing the suspension to absorb shocks during movement. As the tank moved across rough ground, each wheel could move independently. This allowed the heavy vehicle to maintain traction and stability even when crossing rocks, trenches, or broken battlefield terrain. Supporting these wheels were the wide steel tracks, another critical element of the Tiger's design. Each track link distributed the tank's massive weight across a larger area of ground. Without these wide tracks, the 50-ton tank would quickly sink into soft ground. Instead, the track system allowed the Tiger to move across mud, snow, and uneven battlefield surfaces. At the front of the track system sat the drive sprocket, This large toothed wheel connected directly to the transmission, converting the engine's rotational force into the movement of the tracks. As the sprocket rotated, it pulled the track forward around the road wheels. This continuous movement allowed the tank to crawl steadily across terrain that would stop most vehicles. At the rear of the track assembly, an idler wheel helped guide and tension the tracks. Maintaining proper track tension was essential to prevent derailment during movement. Together, the suspension, wheels, and track system formed a powerful mobility platform. But even with these systems working perfectly, the Tiger still depended on one critical element: its massive engine. To move a machine weighing more than 50 tons, the Tiger relied on a powerful gasoline engine. Hidden in the rear compartment was the Maybach HL230, one of the most important mechanical systems of the tank. The Maybach HL230 was a large 12-cylinder engine capable of producing around 700 horsepower. This immense power output allowed the heavy Tiger to move across difficult terrain. Inside the engine block, pistons moved rapidly within large cylinders, converting the combustion of fuel into mechanical rotation that ultimately powered the entire drivetrain of the tank. However, generating power was only part of the challenge. The engine also required an efficient cooling system to prevent overheating while operating inside the tightly packed rear engine compartment. Large cooling fans and radiators were installed around the engine, constantly circulating air and coolant to regulate temperature during operation, especially during long movements or intense combat conditions. Once the engine produced rotational power, that energy had to travel through the transmission system. This complex mechanical assembly controlled speed, direction, and torque delivered to the tracks. The transmission allowed the driver to shift between gears, balancing power and speed depending on terrain conditions. Lower gears produced stronger torque for climbing or crossing difficult ground. From the transmission, mechanical power moved forward through drive shafts inside the hull until reaching the large drive sprockets connected directly to the tank's track system. As these drive sprockets rotated, they pulled the heavy steel tracks forward. This movement transformed engine power into the slow but unstoppable advance of the Tiger tank. Together, the engine, transmission, and track system formed the mechanical heart of the Tiger. But how effective was this massive machine when tested against real obstacles on the battlefield? To understand the real strength of the Tiger, engineers often tested the tank against difficult terrain. Only through these trials could they measure how the massive vehicle performed under real conditions. One of the first challenges was climbing steep slopes. With its powerful engine and wide tracks, the Tiger could slowly crawl upward while maintaining traction across loose soil. One of the first challenges was climbing steep slopes. With its powerful engine and wide tracks, the Tiger could slowly crawl upward while maintaining traction across loose soil. Another obstacle commonly used in testing was the trench. Tanks needed enough track length and traction to climb down one side and power up the opposite slope. With its long hull and strong drivetrain, the Tiger could cross trenches wider than many smaller tanks. The suspension helped keep the tracks engaged with the ground. Engineers also tested the tank against heavy obstacles placed directly in its path. These tests revealed how the suspension and tracks handled sudden impacts. When the massive Tiger rolled over vehicles or debris, its weight alone could crush the structure beneath it. Few machines on the battlefield carried such enormous mass. However, this power came with a cost. The Tiger consumed large amounts of fuel and required constant maintenance to keep its complex mechanical systems operating reliably. Despite these challenges, the Tiger remained one of the most feared tanks of the Second World War. Its combination of armor, firepower, and engineering made it legendary. But to truly understand the Tiger's place in history, we must compare its design and capabilities with other tanks that fought on the same battlefield. To fully understand the Tiger's reputation, it must be compared with other tanks of the same era. Only through comparison can we see what truly made this German machine different. One of its most common opponents on the battlefield was the American M4 Sherman. Thousands of these medium tanks were produced and deployed across multiple fronts. Compared to the Tiger, the Sherman was lighter and far more mobile. Its design focused on reliability, speed, and mass production rather than extreme armor protection. In contrast, the Tiger prioritized armor thickness and firepower above all else. This made it extremely dangerous in direct engagements against most Allied tanks. Another famous opponent of the Tiger was the Soviet T-34. This tank introduced a revolutionary design that balanced armor, mobility, and production efficiency. The T-34 used sloped armor, allowing thinner steel plates to deflect incoming shells. This design made it both lighter and surprisingly resilient on the battlefield. Even so, the Tiger's powerful 88mm cannon could destroy many enemy tanks from long distances before they were able to respond effectively. However, the Tiger's enormous weight and mechanical complexity also created challenges. It required more fuel, more maintenance, and more logistical support than most tanks. For this reason, while the Tiger was extremely powerful in combat, it could never be produced in the same numbers as simpler tanks like the Sherman. In the end, the Tiger was not just a weapon. It was a symbol of engineering ambition, representing the strengths and limitations of complex military technology. When Tiger tanks entered combat, their greatest advantage was range. The powerful 88mm cannon could engage enemy armor from distances where many opposing tanks struggled to respond effectively. In open terrain, this long-range firepower gave the Tiger a significant tactical advantage. Crews could detect and destroy enemy vehicles before they approached effective firing distance. However, battlefield success depended on more than a powerful cannon. Situational awareness, crew training, and coordinated support from other units also played critical roles in combat effectiveness. Against multiple Sherman tanks, Tiger crews often relied on distance and positioning. By engaging from defensive positions, they could maximize the strength of their armor and firepower. The Sherman, on the other hand, used numbers and mobility to compensate for lighter armor. Groups of tanks would maneuver together, attempting to flank heavier opponents. Soviet T-34 units applied similar tactics. Their speed and maneuverability allowed them to close the distance quickly, reducing the advantage of the Tiger's long-range weapon. In close combat, the battlefield became far more dangerous for the heavy German tank. Enemy vehicles could attempt to attack weaker side or rear armor. Urban environments created even greater challenges. Narrow streets, limited visibility, and hidden ambush positions could reduce the effectiveness of long-range weapons. Despite these risks, well-positioned Tiger tanks remained extremely dangerous opponents. When supported properly, they could dominate large sections of the battlefield. Ultimately, the Tiger's battlefield story was shaped by both engineering brilliance and practical limitations. Understanding both sides reveals why this machine remains legendary today. While the Tiger was a formidable weapon, building such a machine required enormous industrial effort. Each tank demanded large quantities of steel, skilled labor, and complex manufacturing processes. Unlike simpler tanks designed for mass production, the Tiger was engineered with extremely precise components and heavy armor plates that required careful machining and assembly. This complexity made the Tiger expensive and time-consuming to produce. Factories could build far fewer of these tanks compared with lighter armored vehicles. During the war, fewer than 1,500 Tiger tanks were manufactured. In contrast, Allied factories produced tens of thousands of Sherman and T-34 tanks. This difference in production numbers played a critical role on the battlefield. Even the most powerful tank could not be everywhere at once. Nevertheless, when Tiger units appeared in combat, their presence often forced opposing forces to reconsider their tactics and engage with extreme caution. For many Allied soldiers, the silhouette of a Tiger tank became a symbol of danger. Its thick armor and powerful gun earned widespread respect. Even decades after the war, the Tiger remains one of the most studied armored vehicles in military history, admired for its engineering and feared for its battlefield power. Today, restored Tiger tanks displayed in museums allow engineers and historians to examine the design of this remarkable machine up close. Through these machines, we can still see how engineering ambition, battlefield necessity, and industrial reality combined to create one of the most iconic tanks ever built. Even after the war ended, engineers around the world continued studying the Tiger's design. Its armor layout, powerful cannon, and mechanical systems provided valuable lessons for future armored vehicle development. Many later tanks adopted similar principles, balancing firepower, protection, and mobility. The Tiger demonstrated how engineering choices could dramatically influence battlefield performance and tactical possibilities. However, the Tiger also revealed the limitations of extremely complex designs. Advanced machines could deliver impressive performance, but demanded significant resources and maintenance. Modern military engineers often study this balance carefully. A successful armored vehicle must combine power and protection with reliability and practical production capabilities. The Tiger remains one of the most recognizable tanks ever built. Its distinctive silhouette and long cannon have become iconic symbols of armored warfare. Historians continue examining the role of the Tiger in major battles. By analyzing combat records, they can better understand both its strengths and weaknesses. Surviving Tiger tanks preserved in museums offer a rare opportunity to observe this engineering masterpiece in person, revealing details that photographs and documents cannot fully capture. Standing beside such a vehicle, it becomes clear how massive and imposing the Tiger truly was, far larger than most tanks that fought during the same conflict. For historians, engineers, and enthusiasts alike, the Tiger represents a fascinating intersection of technology, strategy, and industrial capability during a critical moment in history. And even today, the story of the Tiger tank continues to inspire curiosity, reminding us how engineering ambition can shape the machines that define entire eras of warfare. Even today, the Tiger continues to capture the imagination of engineers, historians, and military enthusiasts around the world who study its design and battlefield impact. Part of this fascination comes from the sheer scale of the machine. Standing beside a Tiger tank reveals just how massive and imposing it truly was. The thick armor plates, enormous cannon, and heavy suspension system together created a machine that seemed almost unstoppable on the battlefield. Yet history reminds us that even the most powerful machines must operate within the limits of logistics, production capacity, and strategic planning. The Tiger represented an extraordinary achievement of wartime engineering, but it also demonstrated the challenges of maintaining complex military technology during large-scale conflict. For historians and engineers, studying the Tiger reveals how design decisions influence real battlefield performance and long-term military strategy. Every component of the tank, from the massive cannon to the complex drivetrain, tells a story about the priorities and ambitions of wartime engineering. Today, preserved Tiger tanks allow us to examine these engineering ideas directly, offering a rare window into the technology of one of history's most intense conflicts. Through careful study of machines like the Tiger, we gain a deeper understanding of how technology, industry, and strategy shaped the course of modern warfare. And perhaps that is why the Tiger tank still stands as one of the most legendary armored vehicles ever built. More than 70 years later, the Tiger tank still represents one of the most remarkable engineering achievements of armored warfare, a machine that continues to fascinate historians, engineers, and military enthusiasts worldwide. Its design combined massive firepower, heavy armor protection, and complex engineering systems, creating a vehicle that shaped both battlefield tactics and the future evolution of armored vehicle design. Yet the Tiger also reminds us that technology alone cannot determine victory. Logistics, production capacity, and strategy ultimately shape the outcome of every war. Through machines like the Tiger, we gain a deeper understanding of how engineering ambition and battlefield necessity shaped one of the most intense periods in modern history. Today, preserved Tiger tanks in museums allow new generations to study this legendary vehicle up close, revealing the details of its design and the story behind its creation. If you enjoyed this deep analysis of the Tiger tank and its engineering, there are many more fascinating military technologies waiting to be explored. From legendary tanks to modern weapon systems, each machine tells a story about innovation, strategy, and the constant evolution of warfare. If you want to see more detailed breakdowns of historic military machines, consider subscribing to the channel for future episodes. Your support helps us continue exploring the engineering behind the machines that shaped history, one vehicle and one system at a time. And until the next episode, thank you for watching and keep exploring the engineering of war.